Okay, we have recognized that if image size is 4000 and 3000 pixel. So first of all, we found that how many then RGB we have 8-bit reserved for red, 8-bit reserved for green, 8-bit reserved for blue, and altogether 24 bits, which means 3 bytes. That part clear? Is it clear?
Right. Yes.
Right. Then, what is the total number of pixels in this image? 4000 horizontal,
7,000.
vertically. Then what is the total number?
7,000.
Is it 7000?
4,000 plus 3,000, right, sir?
Yeah. Is this the way that you are finding the area of rectangle?
Oh, area. Oh, sorry. 100. I mean, 1, 2 with 6 zeros, so 12 million.
1, 2 with 6 zeros. This is the number of total pixels. No? This is the square pixels. Square pixels means the total pixels.
Yeah.
So just see, okay. So horizontally in your house, maybe let's say horizontally you have 10 tiles, and then vertically you have 8 tiles, floor tiles. How many total tiles? It's not
Okay.
10 plus 8, 18, no. It is 10 into 8, no.
Yeah.
Mm. So you have this number of pixels. This number of pixels mean how many bytes? Then size equal to, you know, the number of pixels. This is like the cupcake example I said. If one cake
Yeah.
in one cupcake is 20 rupees, what is the price of 100 cupcakes? So something similar to that. So do you need any kind of formula to calculate
Mhm.
this? I don't think. That's why I said it's
No.
common knowledge. It's common. It's common knowledge. If you know the area, if you know how many pixels are there, if you know the size of one pixel, this is the number of bytes in your image. So what is the value? Value is 36 million. 36 million. And you can divide by 1024 to find how many kilobytes. How many kilobytes? 36 million divided by 1024.
35156.
3
35,156.
35,136. That is in kilobyte.
156.
But what is the size in megabyte? You can divide again by 1024. Then you can find the value in megabytes, which is equal to 3.4.
34.
3.4 megabytes. So that is the size of image. If image is 4000 by 3000 pixels, then altogether 12 million pixels. We call this as 12 MP sometimes. 12 megapixels.
Right.
2000 into 2000, 12 million pixels. We call 12 MP. Image is 12 MP. And what's the size of average size of image is 3.4. That is the maximum it can go. It can be less than that. Can be less than that based on the compression or based on any. So there are compression algorithms because you can't store the image in original format because it might waste your resources. Therefore, in some cases, so is this 3.5 or 34? So 3.45, yeah, 3.5, no? Correct. So value is correct. Let me use calculator.
It's 34. Like, when we divide the 35136 is 30.
Okay, let me try. It's 36 million. You have to divide by 1024. Again divide by 1024, which is 34. Let's say I asked 34. It's 34 megabyte. Clear? Hello?
Hello?
Clear on this? Clear on the calculation?
Yes.
Okay. So can you do the balance, other two, quickly? Please do these two.
Okay.
Okay. Okay. Let's do the calculation quickly. And it is 4 inches and 3 inches. So one side it is 100 pixels. Then 4 into 100. This is the number of pixels. Total pixels. Total pixels. So the width side you have 4 into 100 pixels, because 400, and the height side you have 3 into 100 pixels, 300. So altogether it is 400 into 300, which is equal to 12 and 0000, 120,000 pixels. So then you know the size. Then size is equivalent to 120,000 by 3 bytes, so which is 360,000 bytes. You have to divide by 1024, which is equivalent to roughly 350. What is the answer? You got 356, is it?
351.6.
3.1.6. Okay. Can be. Okay, you have to exactly divide by 1024 and then you will get the answer. And let's 360,000 divide by 1024 and we'll give 360,000 divided by 1024. Yeah, 351.6, somewhere around that. Let's go to the basic one. 60 divided by 1024 is equal to 351.56. Yeah, that is the value. KB 5625. That is the exact value. Okay, then color mode is, let's say color mode is RGB 32-bit. For an example, in this image, same image, I'm going to change this color mode, image mode. I'm going to change this to 32-bit color. 32-bit color means full HD, full high definition image. RGB 32-bit.
Okay.
Which means the image will now get how many colors? Image will now get how many colors? So 32 reds, 32 greens, and 32 bits altogether. 32 reds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 31, 30, 32 reds, 32 greens, 32 blues. Altogether, how many bits? Total bits?
32,768.
Is it 32 bits per one color?
Yeah.
Per one color. For 3 colors, it is 96, no? Bits for all 3 colors. Correct or wrong? 32 per one color mean 96
Yeah.
all 3 colors. So how many bytes then? How many bytes? 96 divided by 8 is equivalent to 12. 12 bytes. 12 bytes per one pixel. Now it's asking what is the value. So what is the value? So you know, so earlier it was 3 bytes. Earlier it was here 3 bytes. But now you have this number of pixels. So this is the number of pixels. You have to multiply it by 12 bytes, each with 12 bytes. So now the total will be, yes, 144, 0000. So this is the value.
Right.
This is the bytes. So this is equivalent to, yes, it's equivalent to 1.4 million for 40,4000 and divide by 1024 will give you 1406 and again divide by 1024 will give you 1.3 megabytes. Is it correct? Or you got some?
Yes, sir.
It's 1.3 megabytes. Correct or wrong?
Yes.
1.3 megabytes. So let's check this. Let's check this with actual example. Let's go to Photoshop. I'm going to take a new image, file new image. First image size, let me know what is the size of first image. 4 inches and, yes,
Uh,
4 by 3 inches, no?
the
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 question,
second question, sir.
second question, yes.
Yes, 4 inches by 3 inches.
4 inches by, let's calculate some, why this is slow. Okay. So it is 4 inches, 4 inches by 3 inches, 4 by 3 inches. What is the resolution? Resolution 100 pixels per inch, no? Siddharth, hello.
Yeah, 100
pixels per inch. Then you can
Correct?
see the size. What is the image size? Here, 351.6K.
6.
Right. So if you increase this image, same image, you are going to change the color mode. RGB. Now what is the color mode? RGB 32 bit.
Yeah.
Here you can see 351.6K. I'm going to change that to RGB 32 bit. Now you can see it's 1.37 megabyte.
Oh,
Can you understand this screen now? So this is what
yes.
the file new screen in Photoshop. Most of you we are using this file new window, but we don't know how this calculation happens. But if you
Yes.
know the theoretical part, how this happens and all, now you know what's the it's not a big thing. This is the magic of raster image. Raster images are created using pixels. But let's say you have few pixels, like 1 pixels per inch, 4 inches, 3 inches, 1 pixel per inch, only 1 pixel. Then you have 36 bytes because it's only 1 pixel is only 3 bytes. 4 into 3 is 12, 12 into 3, 12 into 3 is 36. Okay, it's very small. If you take a printout of this image, if you take a printout of this, what is the printout size? මම printout එකක් ගත්තත් මේ printout එකේ size එක කොච්චරද?
Uh,
What is the size of this printout? I use 4 by 3 inches and then 1 pixel per inch.
yeah.
What is the printout size?
Would it also be the same size?
Yeah, it's same size. 4 inches, 3 inches, same size. Only thing is you can show this. You in your printout, you will see how many pixels. In your printout, you will see 4 into 4, 4, 4. Altogether 12 pixels. That is the maximum that you can see. 12 pixels. So you will maximum see 12 colors in this image. Maximum, if each pixel with one color, then you will see 12 colors. No, that is the maximum. You can go. Understood?
Yes, sir.
But size is 4 inches by 3 inches. Let's have the same size. 4 inches by 3 inches. 4 inches by 3 inches. I'm going to change this to 10 pixels per inch. Resolution, I'm going to change 10 pixels per inch. Now, the same printout size. But now you can see more colors. Why? Altogether, you will have, here you have 40 pixels, down you have 30, 40 into 30 means, altogether you will see how many pixels? 40 into 20, sorry, 40 into 30 means 1200 pixels. So you can see, you can go maximum 1200 colors, no? Understood? Okay. Then, so let me increase this to the same size. Again, I'm going to have the same size, 4 inches by 3 inches. And I'm going to change this to 100 pixels per inch. Now, I'll draw this. So this is the image that okay. Now you can go here, you can see, now here you will have this direction, you will have 400 pixels, 400 pixels. So this direction, vertically you will get 300 pixels, which is altogether 400 into 300 means, what's the value? 120,000. So you can go for 120 colors, 120,000 colors. But still the size is 4 inches and 3 inches. Still the size is 4 inches by 3 inches. Understood?
Yes, sir.
Okay. So then what will happen when you increase the resolution? When size remains same and increase in the resolution, it will increase the image size as well as the image quality. Image size, image quality, number of colors that you can represent, it will increase everything. Understood?
Yes, sir.
Okay, that is about the raster graphics. So bitmaps, you have these pixels and then bit depth, how pixels are represented, and what will happen here? What will happen when you magnify? Or what will happen? How this bitmap file size is decided? It depends on the pixel color scheme. So all these are theoretical parts here. How to find bits, and likewise, they have given sizes, all these things and calculations. That is about this lesson part. I think now you can go and read the book and you will understand it easily.
All right.
Okay. Then next thing is sound. Next thing is sound. In sound, basically we will, in real world, we will go for analog sounds. In real world, we can see analog sounds. Our voice, music, everything comes in analog format. But in computer, we have to convert these sounds to digital format. So this is done using 2 steps, right? Write down the heading. Write down the heading, this one, same one. Representing analog sounds in digital format. Representing analog sounds in digital format. Representing analog sounds in digital format. Okay. Then
Yes.
represented analog sounds in digital format. Okay, represented analog sounds in digital format. This is done basically 2 steps. 2 basic steps to do this. The first one is called sampling, and the second one is called quantization. Sampling and quantization. Okay, when you have analog sound, what you have to do is you have to sample the sounds. Sampling means you divide the sound wave into equal periods or equal proportions. Quantization means assign a value or value level. So if you increase the sampling rate, means per second how many samples that you take. So assume that per second per second, you are going to take 10 samples. This is like, this is similar to the image resolution. Okay, image resolution. If 1 inch has 10 pixels and 1 inch has 100 pixels, which is more quality? 1 inch with 100 pixels or 1 inch with 10 pixels? Which is more quality? More quality, yeah. Hello?
Hello, sir. Can you hear me?
Yes. If you are getting a pix, if you are getting an image, so one image, 1 inch with 10 pixel, another image, 1 inch with 100 pixel, which is more quality.
Hello?
Hello, you can't hear me properly? One image you have 10 pixels per inch and second image you have 100 pixels per inch. Which is more quality?
The 100
The one with 100 pixels. Yes, one with 100 pixels. It is more quality. One with 100 pixels is more quality. Yes. Then similar to that, so here, if you take, okay, sampling, per second, how many periods is sampling? Value of each is quantization. Okay, let me show an image. I'm going to take this image, I'm going to copy the image and let me show. Let's paste this. Okay. Here, this is the analog signal. This is the analog signal. And you can see here t is, let's say t is 1 second. 1 second is divided to 1, 2, 3, 4, 5, 6 portions, 6 places. 1 second divided to 6. Then in each 1/6, then each t, you are taking the value. First it is 4. The second one it is 6. Third one it is 5. Fourth one it is 3. Fifth one 1. Fourth one, sorry. Fifth one, sixth one this 2. Okay. After doing that, you represent the particular signal in binary. 4 is 100, 6 is 100, sorry, 110, 5 is 101. So likewise you represent, and this is what the digital signal is. Understood the mechanism or not?
Yes, sir.
Right. Okay. So let's say if you have, okay, let's do this. Let's do this once and see. So let's say if you have okay, eight samples, and here you have, sorry, 10, you have 10 samples and 8 quantization levels. These are the 8 quantization level. The first level is, let's start from the last one, 0, 0, 0. The next one is 0, 0, 1. Next one is 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. These are the quantization levels. Here, the other side you have sampling. Let's say this is T, this is 2T, this is 3T, same periods, 3T and 40, 5T, 60, 70, and 80. So these are the, here this side, X direction, you have sampling. Y direction, you have quantization. And let me draw my signal. This is my signal. I'm going to draw this using this symbol. Okay, let's draw this curve. Okay, this is my signal. Let's say I'm going to draw this signal. Okay, this is my signal. Okay, can you write down the digital code for this one? This is my analog signal. Can you write down the digital code for this one? Quickly. Okay, let me help you. The first one is 4. 4 means, so here this one is 5. 5 means, so 5 you can say 101. That's 2T. 2T it's in the second T, it is 001. And third 3T, it is, you can say 010. Take the highest value. Fourth T, it is 011. And fifth T, it is again 40 and 50. Again, you have the 011. And then 60, it is going down. You can say 010. 70, it is 001. And 80, it is 010. So this is what? This is my binary signal. But make sure not that this is always. So let me write the digital signal here after drawing this. Okay. After writing this, let me erase this and mark this in this chart. 101 is this one. I'm going to color this. Orange color. Then the next one is 001. 001 is this one. Next one is 010. 010 means this one. Next one is 40. 011. 5T, it is 5T, it is again 011. Let's see. 5T, it is again 011. 60, it is 010. This one. 70, it is 001. And 80, it is 010. This one. Okay, if you try to regenerate the symbol, regenerate this one, I'm going to regenerate this. I'll start from here. I'll go here, 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 this one, and this one. You can see the regenerated signal is not exactly the same. There will be minor changes, but mostly it's okay, but there will be minor changes. So that's why when you record analog audio, using digital, that's why when you save analog audio using digital format like MP3, you will not get exactly the same quality. So if you want to improve the quality, what you can do? If you want to improve the quality, you have to increase the number of samples per second. You have to increase the number of samples taken for second, and you have to increase the quantization levels. Understood? Not just sampling, you have to increase the quantization level. Okay, so
Yes,
that is about sound representation. I think better you can, so after this, better you can write down this, draw this and show. This is analog sound, and how you convert, you have to take, so here this side you have the X direction. So X direction you take quantization level. Quantization levels. Y direction you take sampling. Sampling. X direction you have quantization levels, and sampling rate is Y direction. What will happen if you double the sampling rate? What will happen to the sound? Double the sampling rate. That means you have now 16T. Instead of 40, you are going to include 16T. What will happen to the file size?
it would increase.
Yeah, it will increase and it will double, no? Because this 16T, 8T means 8 into 3. 3 into 8, no? So altogether, this is 24 bits. But if you have 16, it will be 48 bits. So if you double the quantization, if you increase quantization by 1 bit, if you increase quantization by 1 bit and sampling by 2 times, what will happen? Sampling you double and quantization you increase 1 bit. Then what will be the size?
So could you repeat that?
Sampling you double. Sampling, doubling sample will simply double the bits, no? While doubling the sample,
Yeah.
sampling, you increase 1 bit from this side. 1 bit, that means quantization levels. You have 16 quantization levels. Increase in 1 bit means that will also double. 16 levels and 16, yeah, 16 levels and 16 samples per second. Then what will be the size per 1 second? 16 levels and 16 samples. So what will be the size in 1 second? 1 second size of this audio.
Uh,
16 samples means 4 bits, no? It will take 4 bits.
yeah.
Sorry, 16 quantization levels means, yes, 16 quantization levels means 4 bits. So this sampling is 16. If sampling is 16 per second, you will have 16 such. 1, 2, 3, 4, 5, 6, 7, 8. Likewise, you will have 16 such. 1, 2, 3, and 4. Likewise, 16 such. 16 into 4, what is the value? 16 into 4?
64.
64. 64 bits means how many bytes? Yeah, 16 into 4. This will have altogether 4, 8, and then 16, 4, 8. Right? This is it correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 4, 4, 4, 4. Okay, altogether, how many bits? So this is when you have quantization equal 4 bits and sampling is equivalent to 16 samples per second. So this is the number of bits you will get will be 4 into 16, which means 64 bits, equal to 8 bytes. If you have, okay, if your song or if your sound is, let's say 3-minute sound, if you have 3-minute sound, so what is the size? 3-minute sound, then what is the size of this sound? 3-minute sound, then what is the size of this sound? Then you know, right? This is 8 bytes, 8 bytes per second, 8 bytes per second. So you have to multiply this 8 by 60. Then you can find 60 into, yes, 60 into 8 is, this is 480 bytes per minute. So it is 3 minutes means 480 into 3. So that per minute into, you have to multiply this to 3, then you will get the value.
Oh,
What is the value?
1440.
1440 bytes. It's around 1 KB, 1.2 KB, correct? Around 1.2
Yeah.
KB. You divide by 2, so divide by 1024.
No, 1.4 KB.
1.4. 1440, yeah, 1440 divided by 1024 is less, 1.4 KB, around 1.4 KB. So now can you understand how sound is recorded and sound is converted to digital, and how the size of sound is maintained and increased?
Yes, sir.
Okay. So if okay, if a 3-minute MP3, if you get 3-minute MP3, MP3 or a 3-minute digital sound with let's say 3-minute digital sound, it's, let's say it's 3 megabyte, means you can decide, okay, this is 1 KB, 1 KB, then 3-minute sound is 3 megabyte, then it's like you will have 16 quantization levels with, so because actually it's more levels, more than 16 levels, and more than 128 samples per second. So MP3, I think you have heard the qualities of MP3, 92K, 128K, likewise you have 256K. There are
Yeah.
qualities for MP3s. No? These qualities are actually the sampling rates. Qualities are sampling rate. When you increase the sampling rate, the sound quality will be really, really high. But file size will also be high. If you increase the quantization level, same thing will happen. Okay, I think now you can, you know, this how these sounds are represented, how these images are represented in computer, and how the size is calculated. Please remember these things. Right? Please, I have recorded the second part. I can share this with you,
Yes, sir.
not the initial part, but second part I have recorded how to represent sound and videos, audios. I'll share that with you. Right? You can just
Yes.
watch this again and again and remember the things. Okay, in your book, the next thing is about, okay, sound representation and analog to digital conversion. And this is amplification, amplified sound. And these are the samples, sampling it's given. And not just sampling, you have quantization levels. Right? But that is, I think, it's not really given. But there's something, the other decision, so this is theoretical part. Right here. So if you use too few, if you use too few samples, so there will be significant quantization error. Understood? Is it true or false? If you use too few samples, there can be quantization error.
Yeah.
Because let's say, okay, let's say something like this. Let's go to our sound word file. I'm going to copy this one and paste it in my new page. Okay, assume that this is my sound. And insert, and this is my sound. It's going up, going down, going up, going up, going down. Okay, this is my sound. Assume this is my sound. So can you tell me the quantizations for first one? T1, what is the value? T or T?
0, 0, 0.
Okay, let's say 0, 0, 0. What is T2? T2.
0, 1, 1.
T2, okay, 0, 1, 1. 0, 1, 1 is, you take this, okay, right. T3?
0, 0, 0.
T4?
0, 1, 0.
Okay, I'm going to take your one, right? Next one.
0, 1, 0. Is it?
0, 1, 0.
Is it for 5T?
Yeah, 5T. 5T. It's
Or is it high?
5T. 40, you said 0, 5T.
Um,
Okay,
0, 1, 1.
okay, I'll give you a suggestion. Take the middle value. Take the middle value. Middle value means this one. Okay, don't take the corner values, then you will get an issue. Maybe take the middle value. Let's take the middle
Okay.
here. This is 1, 1, 0. Second one middle value is this one, no? 0, 1, 1.
Yeah.
Third one, the middle value is this one, 0, 0, 0. Fourth one, the middle value is again somewhere here. It is 0, 1, 1. Fifth one, the middle value is 1, 0, 1. Sixth one, the middle value is 0, 1, 0. Then seventh one, the middle value is, sorry, sixth one middle value is 0, 1, 0. Yeah. Seventh one middle value is here. You can say the same one. Eighth one middle value is here, 1, 0, 0. Okay. So this is where the error comes. This is where the error comes. So I am going to explain the theoretical part practically. So let's take this signal. Let's take this signal and redraw the signal according to these values. 1, 1, 0 is here. I'm going to color this. So then 0, 1, 1 is 0, 1, 1 is here. I'm going to color this. Then next one is 0, 0, 0. It's here. Next one is 0, 1, 1. It's here. Next one is 1, 0, 1. It's here. Next one is 0, 1, 0. It's here. Again 0, 1, 0. It's also here. Next one is 8. 1, 0, 0. 1, 0, 0. It's here. Okay, I'm going to draw the signal now. Let's insert the same thing. Start from the middle. This one, and going up. This one going up. This one going down. This one, and this one. Let's enter. You can see the resultant signal. Is it same or different?
Different.
Yeah, result is far different than the first one. So why? What's the reason? The reason is you don't have enough samples. So this is the original signal, but this was the one which is digitally created. So it's different. It's different from the original one. This happens especially when samples and quantization, the sampling size is too low. So there will be error. And not only that, another thing that you have to consider is Nyquist theorem. Nyquist theorem, right? Nyquist theorem is noise. Nyquist theorem described about the noise. I think here they have not explained about the Nyquist theorem. So according to Nyquist theorem, the sampling size must be done at the frequency at least twice highest frequency as in the sample. So Nyquist theorem එකේ කියලා තියෙන දේ තමයි. So what they have explained. So you have to take the twice of the highest frequency. Twice of the highest frequency. So you have to go and see the signal. You have to go and analyze the signal first. And then you have to take 2 times of the highest frequency signals to stop damage in the sound signal. So that is a theoretical part. So you have to take, this is the highest frequency. Here you can see this is the highest frequency. This is highest change. This is highest frequency. Highest frequency is not highest value. So what the change in rate, highest change in rate is this one here. Quickly it's going down and changing. This is the highest frequency.
Right.
You have to take samples 2 times of highest frequency. That means you have to divide the particular part at least to 4 sessions. At least to 4 samples. 4 samples means how many total samples? This one actually you have to divide to 4 because this is according to Nyquist theorem. If you take 2 times, you divide by 2, still not enough. You have to divide this into 4. This into 4 means all 8 into 4. So you have to divide this to 38. Sorry, 32. No, because one portion you are going to divide for 4. For 8 portions, it's 32. If you sample this at least with 32 bit, 32 samples, you can regenerate the signal. You can try this at home, right? So draw this and show the error. Draw this and show the error. Not just that, try to sample this to 32 per second. Try to sample this to 32 portions. That means same signal, divide this to 32. 32 and take the quantization levels. You will get a signal which is more closer to this one. Make a ළඟින් යන එකක් වාට හම්බ more closer to this one, not the exact one again, but you will at least get a signal more closer to the original signal. Otherwise, if you take very small frequency, that will definitely damage the very small sampling rate, then that will definitely damage in the original signal. So remember the Nyquist theorem. Nyquist theorem says 2 times of the fastest or 2 times of the highest frequency. Understood?
Yes, sir.
Okay, do this at home. Okay, draw this and show the error. So meanwhile, read the book.
Yes.
I'm referring to the book. So whatever mentioned here, I'm referring to that. But it is theoretical. To understand that, you have to go and do that. And then actually we have to discuss only 2, that is lossless compression and lossy compression. So that is very small part. I'll discuss that in next day. And with that, the particular lesson is over. So next day we have to start this communication and internet technologies. So actually we have done part of this lesson. We have done part of this lesson. And I think we have to do the HTML parts and CSS part, JavaScript part. And some advanced parts are not there in the S level. So, but we discuss about this cable types, internet and services of the internet. What is WWW? This theoretical part, client server architecture. We have discussed about these theoretical parts. Bit streaming. Right. IP addressing. I think we have discussed that part as well. I'll go through this quickly, but we have discussed most of the things related to this. Then the network, I have discussed that as well. 6 addressing domain names, yes. Then the HTML part, then the JavaScript part, and then the PHP part. So that is the basic that we have to learn. I think we can quickly finish chapter 2 because we have almost discussed everything. So we can quickly finish chapter number 2. Okay, so chapter number 1, in order to finish chapter number 1, you have to do this exercise home. So sample this to 32 and see. Okay. Okay, finish drawing or still drawing?